Today we're going to talk about strategies for approaching hard natural deduction problems. We'll look at one example this time and see two of the three strategies in action. So, the first strategy is to begin with the end in mind. Look at the form of the conclusion. What rules lead to that form? So, if you see that the conclusion is P and Q, think you might need to use conjunction. If the conclusion is X or Y, you might need addition or constructive dilemma, something like that. Can you apply a rule to the conclusion? Make a note of it next to the problem. That might be the last rule you use. If you see something like not A and B, well, remember, you could do De Morgan's and get not A or not B. That would be a good thing to write down next to the rule because it might be easier to find the same meaning in a different form in your proof than the exact form of the conclusion. So if there are rules you can apply directly to the conclusion, while you can't write them into the proof, they're a great thing to make note of right next to it. The second strategy is to just make any legal move. Sometimes you don't know where the path is going to take you, but you still need to set out somewhere. If you make moves that you don't end up using later, like simplifying a bunch of things that you don't end up really needing, that's fine. It doesn't make it wrong. It's a great way to get started. So, a good strategy for which legal moves to make are isolate sentence letters and negated sentence letters if you can. Simplification will do that, maybe a modus ponens or a modus tollens or a disjunctive syllogism if you're able to do those. But if you can get a letter by itself, that usually ends up being quite helpful. Do things that change the form of it. In addition to simplification, material equivalence, always a good one to just do when you see that there's a biconditional in your problem. De Morgan's is another good one because De Morgan's changes what things look like a lot, and it might help you see new avenues for what to do in the proof. Distribution can also work there too. And you may even find that it's helpful to do something simple like change the order of things. With commutativity and associativity, you might not even know for sure if you need to switch X and Y into Y and X, but maybe it'll come in handy down the road. And sometimes just getting started not only helps you practically solve the proof, but kind of wakes your mind up and gets you into the proof mode. Remember that you can apply rules of replacement to parts of the line. You don't have to apply them just to whole lines. So if you have if P and Q then R, you could do a commutativity and make it if Q and P then R. Maybe you won't know why you're doing it, but you're getting started. That's important. The third strategy is to go the long way around and do an indirect proof. We've already got an entire video on looking at indirect proofs, so we aren't going to see this strategy in action with this example, but we will see strategies 1 and 2 coming up. And remember, the best strategy you can have, I think, is to have our cheat sheet in front of you. It's got all the rules, and it details how to do indirect proof and conditional proof, and reminds you what the difference is between rules of implication, 1 through 8, and rules of replacement, 9 through 18. So, here's how you might begin with the end in mind. In this example, we have a pretty complex set of premises, not A or C, and A or B. Premise 1. Premise 2, if B and E, then D. Premise 3, E. Therefore, either C or D. So what kinds of things, how might we begin with the end in mind? Well, what kinds of rules result in disjunctions? I thought immediately of addition. Either C or D will get you this answer. If you can prove C, great. Addition will get you C or D. Same thing with D. The other thing that will get you this is constructive dilemma. You're not exactly sure what all you'd need, but in my notes that I've scratched on here, I put question mark, then C, and something else, then D, and either question mark or question mark as a disjunction. There's a lot missing from that, but that is the form it would take if constructive dilemma was important to doing this problem. So what I would do is I would write in my notes, just right there on my paper, if it was the quiz or the homework, I would mark down addition and constructive dilemma right there next to it, just to keep in mind that whatever else I do in the proof, I should remember I might want to do one of those things. For this one, I would even write my formula here, cleaned up a little, if blank then C, and if blank then D, to help me keep in mind what I'm looking for, which pieces of the ending will help me out. And once I've done that, I see that through material implication, I can actually do the first half of this constructive dilemma. That's a good sign, by the way, that we'll be using constructive dilemma instead of addition. Why can I do this? Well, if you remember material implication, or if you took a moment and just looked over your cheat sheet again, just looked at the rules to see if something's already in the form, then you might see that either not A or C can be turned through material implication into if A then C. So let's just go ahead and apply that. Simplification, line 1, and material implication, line 4. You could apply those in the opposite order. That would be totally fine. Doesn't matter, but either way you need both of those rules to get that arrow all by itself and to get that disjunction turned into an arrow. In our notes, I'm just going to put A in there. We've already got if A then C, and I'm going to put A into the disjunction that we'll eventually look for. Now, let's look for D. Well, D's already the antecedent of a conditional. The trouble is, instead of being a regular sentence letter, we've got either B or E. Well, that's not terribly helpful for us. So let's go ahead and see what else we can do. Well, remember through exportation, we might be able to get ourselves if B then D and or if E then D out of this, but it's going to take a little bit of work. I'm going to mark those down. We don't know which one we're going to need yet. And now I'm at a little bit of a loss. So let's just try something. And remember, we're looking to get either if B then D or if E then D. So first thing to do, simplify. It's there in line 1. We can get either A or B. And now, when we think about our constructive dilemma, well, maybe A or B is our correct disjunction. That'll work. Let's try for if B then D. Well, B is right there in the same conditional as D. So we're going to go ahead and try out an exportation. But before we do that, we're going to switch up the order. We switch if B and E then D to if E and B then D. The reason we do that is because of how exportation works. We want to come away with B and D together in the conditional, so we need them next to each other before we apply the next rule. Exportation lets us go from a conjunction as the antecedent of a conditional to two conditionals in one. If conditional, then another. Now we've got if B then D as the consequent of a conditional, which means we can get it through a modus ponens. We've already got E. We should have known it was going to come in pretty handy since it was just sitting there given to us, and sure enough, it will. And now we've got if B then D. We've got all the pieces of our constructive dilemma. We just have to put them together. So we'll use conjunction, and we'll put our two arrows together. And now, when we think about the rule, we should think about it in terms of its input and its output. The rule is written P or Q, if P then R, and if Q then S, therefore R or S. Well, A or B stands in for the first line, P or Q, and the entire mess in line 10 stands in for the second line, They've got the exact same form, so we can plug that into the rule, and we can get our output, C or D. And now that we've got something that matches our conclusion, that's it. We've finished this proof.